Hello, my name is Olamiska Aziza. I am from Binus University, and on this session, I will discuss about my scientific research article. The research title is Examining Changes in Air Quality Levels per and during COVID-19 in DKI Jakarta using Pearson correlation. This is my research background and motivation of this research. As we all knew, air pollution in Jakarta is an ongoing issue that never seems to an end, right? Many international articles and news reports discuss the critical of air pollution in DKI Jakarta. And why is that so? Because the impact of air pollution is quite significant on public health and the quality of human life. High level of air pollution can cause various respiratory disease, heart problems, and even lung cancer, endangering millions of residents. Increased public awareness driven by media and health campaigns has also made this issue a major concern. Recently, the media has highlighted the importance of firm government action to reduce emissions and improve air quality, as well as promoting technological solutions like electrical vehicles and expanding the public transportation fleet. Now, do you all remember about the COVID-19 pandemic? Who would have thought that the pandemic would improve air quality not only in Jakarta but globally? Additionally, rain is often referred to as a natural cleanser of air pollution. And why is that so? Based on research by Vital Strategies and Bandung Institute of Technology, vehicles are one of the largest contributors to air pollution. The COVID-19 pandemic, which forced countries to implement social isolation, significantly reduced vehicle mobility. Furthermore, according to a meteorologist at Environment Agency in Jakarta, rain is closely related to a decrease in pollution levels. And in this study, we will discuss and present statistical evidence to support our hypothesis. And what is the purpose of this research? Since air quality continues to be a topic of discussion, the study aims to identify factors that worsen air quality by providing statistical evidence based on empirical data. Moreover, understanding air quality can help the public avoid exposure to harmful pollutants that can cause health problems, as mentioned earlier, by taking measures such as wearing masks when going outside to minimize the inhalations of pollutants. Air pollution refers to the presence of excessive harmful substance in the air that pose risk to human health, the environment, and the climate. These pollutants can come from natural sources or human activities that have both short-term and long-term health impacts. This research investigates changes in air quality levels before and during the COVID-19 pandemic. By analyzing data from each quarter of 2018 to 2020, the study shows a 38% reduction in vehicle mobility coinciding with a 55% decrease in the number of days with poor air quality. This correlation indicates that reduced vehicle mobility can improve air quality. Using Pearson correlation analysis, the study found a positive correlation between the number of vehicles and poor air quality. Additionally, there is a strong correlation suggesting that high rainfall intensity is associated with better air quality. The study also identifies ozone as the dominant pollutant in poor air quality, which can lead to acute respiratory infections. Next, we go to the methodology. The research method used in this study is data mining. Based on the book titled Data Mining that published in 2023, data mining consists of data collection, data extraction, data analysis, and data statistics. The first step is data collections. We collected data from two sources. There are data.jakarta.go.id and BPS. The following is the sample of collected data. Next is data analysis. Based on our data analysis, there is one data set that's still in the form of categorical data. Now, this categorical data had to be converted into numerical data. Furthermore, from the data analysis results, we also found missing values in the rainfall quantity data. We calculate the average from aggregate data in the same quarter and different years to restore the missing value. And here's the formula of Pearson correlation. But however, for statistical correlation test, we will use Python with the scipstats library. By calling the Pearson function, we input variables and obtain the correlation coefficient or R for each variable. The next step is data visualization, which will be done using Tableau. And then we go to our research results. Based on the calculation, the number of days with poor air quality in 2020 decreased by 55%. At the same time, vehicle mobility also decreased by 38%. Now, to prove this hypothesis, we use Pearson correlation analysis to analyze the correlation between poor air quality and vehicle mobility. The results show a moderate positive correlation with a coefficient of 0.401. Due to moderate correlation, we solved other factors that might have caused the drastic improvement in air quality in 2020. And it was found out that rainfall intensity in 3 out of 4 quarters of 2020 was higher than in previous quarters. We also conducted Pearson correlation analysis to determine the strength of this correlation. The test results show a very strong positive correlation with a coefficient of 0.756. And why does rain could improve air quality? Previous studies have mentioned that rain can push pollutants down. This process known as wet deposition. And what is the highest substance in air pollution? Based on the analyzed dataset, ozone was found to be the most common pollutant. Ozone itself can cause short-term impacts such as respiratory infections. If air quality continues to deteriorate, the number of respiratory infection sufferers could increase. To prove this correlation, we performed Pearson correlation tests, and the results show a low positive correlation between poor air quality and respiratory infection cases. In conclusion, this study provides empirical evidence through Pearson correlation that the reduction in vehicle mobility during COVID-19 pandemic has improved air quality, with a moderate positive correlation of 0.401. Additionally, higher rainfall intensity with a correlation coefficient of 0.756 was identified as a key factor in air quality improvement. The 61% increase in rainfall intensity and 38% reduction in vehicle mobility in 2020 contribute to better air quality in that year. The study also found out that ozone is the main cause of poor air quality, which can also increase cases of acute respiratory infections. The correlation coefficient of 0.36 supports the need for more air quality improvement measure. I'm Miss Aziza. Thank you for listening.